Hello everybody, my name is Bryce, and today I will be your guide to the wonderful world of stem cells. As you may have already guessed from the title, I will be breaking down stem cells into 3 different categories: what they are, why they are of importance, and how can we use them in the real world. Now please, sit back, get comfortable, and prepare to indulge yourself in the wonderful world of stem cells. Now, as I promised, I will be answering the question on everybody's mind: what are stem cells exactly? Now, if we look into the wonderful world of Google, it defines a stem cell as an undifferentiated cell of a multicellular organism that is capable of giving rise to indefinitely more cells of the same type, and from which certain other kinds of cell arise by differentiation. Now, that is a lot of big words, and I plan to break down all of them just for you. Now, there are 4 main points to becoming a stem cell. The first one is that an undifferentiated cell in this case would be a cell that has not yet taken on a role and adopted a personality. It must be a part of a multicellular organism that can reproduce and sustain more stem cells. These new stem cells will either be the same type or other kinds of cells based on differentiation. And differentiation in this case means the new cells produced by stem cells will undoubtedly have a different personality. To better explain this, I will be using this pencil. Now imagine this pencil is a cell in your, let's say, bladder. So it does bladder-related activities, and it performs cell division. Both of the new cells still do bladder activities. So throughout this bladder cell's entire family tree, all these new cells still continue to do bladder-related activities, and that's just what they do for the rest of their life. But with stem cells, it's a bit different. Now the thing about stem cells is that they don't have a personality. They aren't bladder cells or they aren't liver cells. They don't have specific jobs that they have to do. So let's take this pencil for example and say it's a stem cell. This stem cell is just floating around, say, wherever, and it doesn't have a job. But it can take on a job if it sees fit. So say this pencil doesn't have a job. It's just floating around and it performs cell division. So let's break this pencil in half. So now we have 2 stem cells, and so this one, maybe it still doesn't want a job, so it will remain this stem cell. Let's say this one wanted to become, I don't know, maybe a bottle of Tylenol. So now it becomes a bottle of Tylenol, and now it's a Tylenol cell. But this one still stays the same. So let's say this one breaks in half again. Well, the other half could remain a stem cell, and the other half could become, I don't know, a Tim Hortons large T. The whole idea of stem cells and what exactly they are is that they aren't exactly anything other than a cell that can decide to be pretty much any cell it wants to be. Now this is an incredibly unique trait, and as human beings wanting to take advantage of pretty much everything we can, we have put in a lot of effort to trying to figure out how we can use this trait exactly, and there's definitely an infinite amount of possibilities in medical science and, biochemistry science, and basically all sciences where this could come in handy. Now, one of the big problems with stem cells is that they are very difficult to come by. At least back in the day when we first started researching them, they were. And the means of getting them were, let's just say, a bit out of hand. The main way that we harvested these stem cells was a bit controversial at the time, because basically what we had to do is we had to go into aborted embryos, which is pretty gross to think about, and we had to basically remove these cells from the aborted embryos. Because of this controversy, researchers had to figure out a way to get stem cells in a more ethical manner. Most common nowadays are induced pluripotent stem cells, or iPS stem cells. Induced pluripotent stem cells are basically adult cells that have been opened up and changed so that they can be more like embryonic state stem cells. This is a very important method in obtaining stem cells, as it avoided the controversy that stunted a lot of stem cell research. Still to this day, stem cell research causes massive controversy around the world, with people saying things like, we shouldn't try to play God and we shouldn't mess with human life, as well as just the question of how could this research be used. There's a small argument to be made about human cloning at this point in time, but right now it's a little bit vague and there's not enough information to really get a for sure answer about if that's possible or not. Now, up until this point in the video, I've basically only focused on embryonic stem cells, but there's actually another type, and these are called adult stem cells. The difference between embryonic and adult stem cells is just that embryonic stem cells are found in embryos and adult stem cells are found in adult organs. So what's the origin of adult stem cells? Well, surprisingly enough, we aren't quite sure at the moment, and it is still under intense investigation. Adult stem cells are, of course, undifferentiated cells. The only difference is that they are found among differentiated cells in tissues and organs. Much like embryonic stem cells, adult stem cells are able to differentiate themselves into pretty much anything that they want. And I think at this point we know enough about stem cells and how they work, and we can probably move on to how exactly we can use them in the real world. So why exactly are these stem cells so important? Well, the benefits that we can draw from these cells are incredible. Two of the more important uses of stem cells, and the uses that I will be focusing on, are the fact that we can use stem cells for cell-based therapies, as well as testing new drugs and medicine. So how can we exactly use them to test new drugs? Well, we are using them to test new drugs as we speak. The reason that stem cells are so important to testing new drugs is that, in theory, if we have a large amount of stem cells, then we have a large amount of any cells we could possibly want to test on. This, of course, removes the need to have live test subjects such as humans or monkeys or something like that, but it is a little bit more difficult. The reason it is so much more difficult to test on stem cells rather than a live person is that you need all the cells to be exactly the same for the testing to be efficient. Because of that, scientists need to recreate the exact same stem cell every time. Current knowledge, or lack thereof, prevents us from having complete control over stem cells, which makes this task a little bit more difficult than it probably should or could be. Now, to get away from the testing new drugs part of stem cells, I will start to talk about cell-based therapies. And basically what cell-based therapy is it's a solution to the ever-growing problem of organ donors. Now, there is a ton of people out there in the world who need organs to be donated, and there's not quite enough donors to really supply that huge number. Luckily for us, stem cells offer a very massive solution to this ever-growing problem. A cell-based therapy is when we put in stem cells to a damaged tissue or organ, and we can induce that stem cell to grow and fix that broken down tissue or organ. A cell-based therapy is when we put in stem cells to a damaged tissue or organ, and we can induce that stem cell to grow and fix that broken down tissue or organ. If we had a renewable source of replacement cells or tissues, we could consistently treat diseases such as spinal cord damage and arthritis. This type of cell-based therapy can be found today as scientists are discovering ways to basically grow organs. Could you imagine going out into a garden and instead of seeing carrots getting grown in the ground, you pull out, I don't know, a brand new kidney? What if I told you that growing a kidney is actually extremely possible and it's actually recently been done? In the past year, a team of scientists were able to figure out how they could manipulate stem cells into becoming each of the different specific cells needed for a kidney to function. After obtaining this information, scientists were able to manipulate the stem cells in such a way that they were able to make full-fledged, complex kidney tissues. After they got the kidney tissues, they were able to manipulate those into becoming key parts of the kidney. After they were finished, comparing these tissues to that of a real-life human kidney, the resemblance was almost seamless. Unfortunately, this kidney isn't actually able to be transplanted as of right now, but the future is looking bright for stem cells, and this could be an extremely large discovery. This kidney, as of right now, is being used to test, like I said before, new drugs and poisons and toxins, so it's definitely helping in the fight against those nasty kidney viruses. I hope after all this, you now have a better understanding of what stem cells are, why they are important, and how they can be used in real life. I am certainly very excited for the future of stem cell research, and I hope that you are too. Thank you all for watching. I'm Bryce, and I hope you now have a better understanding of the wonderful world of stem cells.